This lesson is on solving a system of linear equations graphically. So to boil it down to the most basic terms, what does it mean to solve a system of equations? Solving a system of equations means to find the values of all variables that satisfy all equations in the system. So I'll say that again because it's very important to understand what you're actually doing. Solving a system of equations, so that means two or more equations. We'll just be looking at two to start with. In Math 11, you'll be looking at three or even more. But when you have two equations, solving that system of equations means to find the values of all variables involved that satisfy all equations in that system. So that will, when you plug those values in for the variables in both those equations, the equations will work out. You'll end up with 5 equals 5 for the equation or something like that, right? It'll work out. You won't end up with 7 equals 5 in one equation. So let's look at a quick example, a simple one. What values of x and y would satisfy both of the below equations? Now I've purposely picked a very simple example here because we can actually guess and check an answer, which I don't want you to do on any of your test questions because you'll be expected to solve them algebraically or graphically as we do in this lesson. So if you looked at that long enough, you might have figured out if x is 2 and y is 1, that will satisfy this system of equations. So we say that is the solution to this system of equations. The answer is literally x equals 2 and y equals 1. 2 plus 1 is 3 and 2 minus 1 is 1. So that works in both of these equations. This is the solution to this system of equations. So we can solve a system of equations graphically. Let's rewrite both equations into slope-intercept form. So x plus 1 equals 3. We need to isolate y for it to be slope-intercept form. So we get y equals negative x plus 3. And x minus 1 equals 1 becomes y equals x minus 1. Basically, you added y to both sides, and then you subtracted 1 from both sides, so you're left with x minus 1 on the left-hand side, positive y on the right-hand side, and then I just brought the y back over to the left-hand side, brought the entire right-hand side to the left-hand side to the right-hand side to get to our standard form for slope-intercept form. So let's graph both of these equations onto the same graph now. So I've quickly graphed this. You should already know how to graph these. Quick recap. Y equals negative x plus 3. Our y-intercept is positive 3. Our slope is negative 1 over 1. The ones aren't written, but it's negative 1 over 1. So that's a rise of negative 1, a run of 1, rise of negative 1, run of 1, etc. That also forms a 45-degree angle with the x-axis. And then our other graph, y equals x minus 1. First, go to your y-intercept, negative 1 is right here. And then your slope is not shown here, but it is. It's 1, and then 1 over 1. So rise of 1, run of 1, rise of 1, run of 1, etc. So you only need to do it once, remember. Y-intercept, form your segment, and then you're done. Just extend it. So what do you guys think is the solution to this system of equations when we do this graphically? What is something that might look like it would be a solution? Well, I hope you said the intersection point. So that intersection point represents a point that lies on both lines. And that's the same thing as saying that it represents x and y values that will satisfy both of these equations here, both of these equations. Since x, y values are just x, y points on both of these lines. So this can be a little bit tricky to understand, but if you kind of get mostly there, then you're doing fine. Mainly just memorize this if it doesn't make much sense. But it doesn't take too much thinking. Just try to think about it a bit, and you'll probably get it. Normally when we solve systems of equations, though, we do it purely algebraically, so you don't need to worry too much about doing it graphically, except more complicated ones actually you use a graphing calculator to do when you're dealing with curves and things like that. So the intersection point here is 2, 1. X is 2, y is 1. And so the values of x and y that satisfy both equations or lines is x equals 2 and y equals 1. So note I use the same equations from the first example where we just guessed and checked, and I showed how we get the same thing here. So remember, the solution to two lines on the graph is going to be the intersection point, and then the x and y values, those are the specific solution. When you give your answer is x equals 2 and y equals 1 is the solution for this system of equations here. So let's look at another one. Solve the below system of equations graphically. 2x plus y equals 4 and 2x minus 3y equals 12. I'm going to go pretty quick here. Let's rewrite both equations in the slope-intercept form so we can graph them easily. And so we've just isolated y there for the first equation. We've isolated y for the second equation. This is just basic algebra, guys. If you need a recap in how to isolate y here, because we're going to slope-intercept form, feel free to find some lessons on basic algebra. I will be adding Math 9 and below lessons later, so you could find those at a later date as well, when you first learn how to do algebra. So now we have both of those equations rewritten into slope-intercept form. Now we can graph both of these easily onto the same graph. And then the main point of this lesson is to show how you get a solution now. The solution is going to be your intersection point. And that is 3 minus 2. Right there, shown in purple. And so we say, as our answer, the values of x and y that satisfy both equations is x equals 3 and y equals negative 2. And this lesson is over. Okay, I take that back. Looks like we have one more example, I think it is. Solve the below system of equations graphically again, but by using a graphing calculator. Okay, so we're using the same system of equations, but we're going to use a graphing calculator this time. You mainly use a graphing calculator in later grades, but it is good to show it to you already. So let's rewrite both equations into slope-intercept form. That's how you put it into a graphing calculator. You need y isolated. So let's isolate those two, and it's the exact same isolation as on the previous slide, so I won't spend much time here. Now, using the graphing calculator, graph those two equations and resize your window as necessary. So it'll show up as something like that on your graphing calculator. Now, use the intersect function on your graphing calculator to find the intersection point of the two lines. On my calculator, intersect is found by pressing the second button and then trace. Use the arrows that show up now to go near the intersection. Press enter to select the first line. Then the cursor should jump to the second line, and press enter again. It may say guess now, so press enter a third time. Your calculator should give you the intersection as 3, negative 2, as shown there. And now the lesson is done.